All right, so you've put in the hard work in the previous modules. You've got a working AI prototype, your data is seamlessly linked to your design, and your technical justification is totally solid. But here is the reality check we all have to face. Just because a prototype is technically sound doesn't automatically mean it's a responsible one. Today, in this explainer, we're focusing on exactly how you make that leap. We're going to look at how to transition your project from something that just works in a sandbox to something that is ethically, equitably, and responsibly ready for the real world. Okay, let's just dive right into it, shall we? To make that transition successfully, you have to subject your prototype to the ultimate stress test. And honestly, it really comes down to three crucial questions. Who benefits, who bears the risk, and who is left out? It's simply not enough anymore to say your AI tool improves some average metric. You have to look closer and ask if that projected improvement is actually distributed fairly, or if it's inadvertently helping some people while leaving others even further behind. To get us to that responsible deployment stage, we've got a roadmap with 5 quick checkpoints. 1. Beyond a working prototype. 2. Assessing ethical risks. 3. The equity distribution matrix. 4. A 4-part justification. And 5. Predicting long-term effects. Kicking things off with Section 1, Beyond a working prototype. Before we can fix anything, we've got to define the stakes. To ground this in reality, we'll use a rural broadband access tool as our case study. This is an AI project designed to help residents find internet providers. So what exactly is ethical risk? Well, it's any way your prototype's design, its underlying data, or its use of AI could cause harm, unfairness, or a loss of trust. And here's the real kicker. This absolutely includes unintentional harm. You don't have to be trying to cause a problem to actually cause one. I mean, if an AI model is trained mostly on urban data, it's probably going to give terrible guidance to rural residents. That is an ethical risk, whether the engineers meant for it to happen or not. Moving right along to Section 2, Assessing Ethical Risks. When you finally bring your project to a capstone panel, or eventually to real-world stakeholders, they're going to scrutinize your work across 4 very specific categories. First, bias. Does the tool perform systematically worse for certain groups? Second, privacy. Does it expose way more personal data than is strictly necessary? Third, transparency. Can the users actually understand how it made its decision? And fourth, accountability. Who catches the errors? Let me give you a very direct warning here. A risk that isn't named in your proposal is a risk that someone else is going to name for you. So own it before they do. So, how do we shift our mindset here? You've already done the deep data analysis, but listen to how a standard technical question transforms into a vital ethical risk question. Previously, you might have asked, who was in your data set? But now, under ethical scrutiny, that exact same data point forces you to ask, does my dataset actually underrepresent the very population this prototype is meant to serve? It's the exact same data scrutiny, just pointed at a much, much harder question. Let's actually look at our rural broadband tool. When the designers looked at their data through this new ethical lens, they found a massive risk. The dataset actually thins out in the lowest connectivity tracts. Think about the irony of that for a second. The exact areas where the need for internet access is the highest are the areas where the data is the weakest. This means the AI's recommendations for those specific residents are resting on way fewer data points and consequently are far more likely to be completely wrong. Which brings us to Section 3, the equity distribution matrix. I want you to really lock in on this phrase, ask what the average hides. It is incredibly easy to build a prototype that helps, say, 80% of your users and reports a wildly positive average effect. But if that exact same prototype actively harms the remaining 20%, which is so often a minority or marginalized group, that harm gets completely averaged away and hidden in the aggregate metrics. To stop that from happening, we use the equity distribution matrix. Let's walk through it for our broadband tool. Think about our subgroup, residents without home internet. The projected benefit of the tool is faster provider info. That sounds great, right? But what's the access barrier? They cannot reach the tool. Why? Because it's an online tool and they don't have internet. The equity verdict here is that they are entirely underserved. It is a fatal design flaw. The tool fails the exact people it was built to help simply because it assumed everyone could access it the exact same way. Now, on to Section 4, a 4-part justification. Once you spot a gap like that, you have to adjust your claims. A standard, technically sound justification might boast, this tool improves access for the community, but we know that's overclaimed now. A properly scoped, ethically defensible justification says, this tool helps residents who already have internet access,
Residents without home internet will need a separate outreach channel like community kiosks. Notice how much more bulletproof and trustworthy that second statement is? Honest scoping is absolutely your best defense.
To guarantee your justification hits that level of bulletproof honesty, it needs 4 key ingredients. First up, the mechanism. How does it actually work? Second, the magnitude. How big of a shift are you expecting? Third, equity. Which specific subgroups get that shift and which do not? And finally, accountability. Who reviews the real-world outcomes? Listen, equity and accountability are not just nice-to-have add-ons. They are the foundational pillars of a responsible justification. This is what proves your solution isn't just a hopeful guess. It's a concrete, testable plan.
Finally, we hit Section 5, predicting long-term effects.
Before your AI ever leaves the demo stage, you've got to ask the really tough questions. Who actually bears the cost if a recommendation is wrong? And crucially, does the gap close or compound? With our broadband tool, if the people who already have some internet use the tool to get even better, faster internet, while the disconnected residents remain completely excluded, well, the connectivity gap hasn't just remained the same. It has actively widened. The prototype accidentally compounded the disparity. Predicting that harm isn't enough, right? You actually have to plan for it. Real accountability means you don't just wave your hands and say, oh, we'll monitor it. You say, we will review subgroup outcomes at exactly 3 months post-launch, and we will pause expansion if the connectivity gap has widened for any tract. You have to name a specific, accountable owner and a clear, non-negotiable condition that triggers a pause. That is what separates a long-term hope from a responsible long-term plan.
I want to leave you with this final thought. What would make you pause deployment? It's arguably the most important question you can answer before a capstone defense or a major product launch. A responsible prototype isn't just one that works. It's one where the creators know exactly when to stop, reassess, and fix who is being left behind. Think about what that specific pause condition is for your own project. Thanks so much for joining me on this explainer, and I'll see you in the next one.